Differentiation, applied maximum and minimum problems. About differentiation. Differentiation is a method of finding the derivative of a function. Differentiation is a process in maths where we find the instantaneous rate of change in function based on one of its variables. The most common example is the rate change of displacement with respect to time called velocity. The opposite of finding a derivative is anti-differentiation or integration. Okay, today we are going to talk about maximum and minimum. If the function is a continuous function in its domain, then at least one maximum or one minimum should lie between equal values of the function. Maximum and minimum occur alternately. As an example, between two minimum there is one maximum and vice versa. If the function tends to infinity as x tends to a or b and f prime x equals to 0 only for one value x, for instance between a and b, then the function is the minimum and the least value. If the function tends to negative infinity as x tends to a or b, then the function is the maximum and the highest value.
The application of derivatives are to determine the rate of change of a quantity with respect to another changing quantity. Then, to determine the maximum or minimum saddle of point of a function, and to determine the concavity and convexity of a function. We will continue with problem statement. A field is to be partitioned into 4 areas and each partition is enclosed by a fence as shown below. The total length of the fence is 200 meters. The question is, A. Shown that the total area of the field is A equal to 100x minus 5/2x squared. B. Determine the dimension of the field that will maximize the total area. C. Find the maximum total area. So the solution for question A is, first, we write the formula for area. The formula for area is A equal to xy. Then we express y in terms of x. 5x plus 2y equal to 200. Then we use y equal to 100 minus 5/2x. Then we solve to get the final answer by using the area formula. We put the value y into the equation and it will be A equal to x bracket 100 minus 5/2x. Then the answer will be 100x minus 5/2x squared.
Determine the dimension of the field that will maximize the total area. First, we need to differentiate the equation of area that we already get from the answer in problem solution A. The first thing that we need to do is rearrange the equation and equate to 0. So it's become 100x minus x over 2 x squared equal to 0. After the arrangement and equate to 0, we can try to differentiate the equation, bring the power of 1 from the variable x and place it in front of x, then it will be 100 times 1, which is 100. For the variable x, we need to minus x power, which is 1 with 1, so the new power for variable x is 0. Repeat the same step for 5/2x squared, and at the end we will get 100 minus 5x equal to 0. And the next step is we need to determine x as a subject, and we get x equal to 20. Then we need find value of y from the equation in problem solution A. We assign x equal to 20 to the equation 5x plus 2y equal to 200, and as a result we get y equal to 50. When we get the value of x, we need to do the second derivative test. The second derivative test is done to prove or check whether the value of x that we get is minimum or maximum value. If our second derivative is greater than 0, then it will be a minimum value otherwise it will be defined as maximum value. So for this step, just take our first derivative test, which is 100 minus 5x equal to 0, and we just differentiate like how we did earlier, and as a result we will get minus 5. From the second derivative, we get no x equal to 20 is a maximum value, so the area is maximum value.
Okay, for the last question, the question asks us to find the maximum total area. First, what we needed to do is to write the formula for the area maximum value. From problem solution A, we have proven the area maximum value equation, which is max area equals to 100x minus 5 over 2x square, and we have the x value, which is x equals to 20 meter. Next, we need to substitute the x value in maximum total area. So as a result, the final answer will be 1000 meters squared. So now our problem is solved.
Conclusion: anything that we learn can be applied in our real life. Therefore, keep learning and contribute our energy and knowledge in order to apply what we have gained in real life, especially during our daily routine and working life.